Hi everybody, it's Miss Austin. I'm going to be doing the lesson 15 practice problems. Number one, it gives us a polynomial in standard form and then a bunch of function notation of points. And then it asks us to rewrite it as a product of linear factors. Well, let me zoom in a little bit here and focus a little bit better. First of all, this is an x to the third in standard, which means if I'm going to rewrite it as a product of linear factors, it's going to have 3 like this, 1, 2, 3. And they're trying to give me those with this information. They want to see if I understand what this means. So remember function notation. This is your x value and that's your y value. So that's the point 0, 6. That's the point 2, -4. It's saying for this polynomial, when you allow x to be 0, the output is 6. If x is 2, the output is -4. Why would they give us this? Because if they give us one that is an x-intercept, I would know that's one of the factors, right? So this point right here, -2, 0, imagine what that looks like. That's touching over here at -2. That's one of my factors. If -2 is one of the factors, then this is x plus 2. So I'm looking for points like this. So here's another one, 3, 0. That'd be right, if that's 2, if that's 3, right there. So it'd be x minus 3. This one, I'm going to write down because I can tell it's -1, 8. That's not an intercept. But that one is 1, 0. So if it touches at 1, then -1 is the factor. Okay, now it's written in factored form. Number 2, select all the polynomials that have x minus 4 as a factor. So you could either do long division or the box. I'm going to do the box. And if it is a factor, then the box should work out. It's kind of a lot of work here, but so I know this is x to the third. So this is x squared. That would make that -4x squared. And notice over here there's no x squareds. So this needs to be 4x squared to make none, because there isn't any. So then this would be 4x. This would be -16x. I need my x's to add up to -13. So this needs to be 3x. So now that's 3. And then look, 3 times -4 makes -12. It works. That's because x minus 4 is a factor. We could also go to Desmos, type this in and see if it touches at x equals +4. Try the next one. It's a lot of good practice, though, with your box as well. Okay, so I know this is x to the third again. And this is x squared, -4x squared. This time, this and this need to make 8x squared. So this would be 12x squared. It'd be 12x, -48x. These two need to make 19. 12, 48, 58. That's 67x. That'd be 67. 67 times -4. Is that going to make 12? No, that's because x minus 4 isn't a factor of this. All right, let's try the next one. Here we go. One of my children is screaming for me. They are unaware I'm making a video. Again, look at this one. This only has x's. There's no x squared, so this is 4x squared. So that's 4x. And then that'd be -16x. And I combine those. Sorry, you can't see that. So that would need to be, 20, 16, 26, 27x. So that'd be 27. Is 27 times -4 going to make -12? No, because x minus 4 isn't a factor. All right, B. Could also do long division. This is x to the third, x squared, -4x squared. These two need to make -1. So this is 3x squared, 3x. That'd be -12x. These two need to make negative 10x. So that would be, I need 2x. So that'd be 2. And 2 times negative 4 makes negative 8. That's because x minus 4 is a factor of this. Yes. And this one, I'm not even going to do the box because it's only x squared. So this is x squared. There's no x's and minus 4. So I could use my Timba puzzle to figure out what are the factors, right? It's going to be 2 of them. What two numbers multiply to negative 4 but add to 0? 2 and negative 2. So the factors of this guy are x plus 2 and x minus 2. X minus 4 is not. Those are the two factors. So just A and D. All right. Number 3. Write a polynomial. One of these, my printout, I'm going to switch over to the book. Write a polynomial p of x with degree 3 that has p of 7 equals 0. So that means when x is 7, the output's 0. They're giving me one of the intercepts, 7, 0. So p of x, I'm assuming they're just going to let me pick the other one, right? Or the other two. So if it touches at 7, I've got, I'm supposed to be using p. No, I'm not, Miss Austin. Come on. Okay. We're writing the right answer down here. It'd be x minus 7 and then any two other ones. I mean, you could also make this one count twice. You could do something like that. That's a third degree, 1, 2, 3. You could do x minus 7 times x plus 3. I'm just making the other two up. There's 3, third degree, 1, 2, 3. All right, number 4. Long division was used here to divide the polynomial function p of x. Once they divided it by x minus 5, and once they divided it by x plus 5. So you see all the work down here, and then they ask us the question, what is p of negative 5? They're asking if we took a negative 5 and plugged it into this function, what would we get? Well, in lesson 15, we learned the remainder theorem. When you divide by a factor, that is the value you would get by plugging that number into the polynomial. So x minus 5, right? Imagine that actually means it would be touching at 5, 0, right? If it's written as x minus 5, and that means 5, 0. So I'm testing the number 5. The remainder is what you would get if you plugged a 5 here, here, and here, everywhere you see x. So if I plugged a 5 into this polynomial, it would spit out a 90. That's what that means. And this one, because it says x plus 5, would actually be negative 5, 0. And this remainder tells me what I would get if I plugged a negative 5 in. I would get negative 5, 40. So now it says, what is p of negative 5? What would you get if you plugged a negative 5 in? You would get that. I can see it by the remainder. I would get 40. What would you get if you plugged a positive 5 in? You would get 90. All right, which polynomial function has zeros when x is 5, 2/3, and negative 7? So these two are pretty easy because it's just the opposites would make those zeros, right? So I'm looking for a negative 5. So both of these are wrong because these both say plus 5. So that works. And then negative 7 is positive 7. Okay. How about 2/3? Now you'll notice they don't write it like this. Okay. So there's kind of a little shortcut here. If you just take that number and put it right here, look, 3x minus 2. Now let me just show you how that turns into 2/3. Let's say we didn't know that the answer was supposed to be 2/3. We would ask ourselves, hey, what makes that 0? You would add 2 over, and then you would divide both sides by 3. This is what it looks like in factored form. So D is the correct answer. All right. Number 6. Oops, I'm going to go back to my paper as my pen bled through. All right, this polynomial, mine's on the other page, but okay, it's on the bottom. The polynomial has known factors at x plus 3 and x plus 2. Rewrite it as a product of linear. Well, this is a fourth degree, so it's going to be 1, 2, 3, 4. I know two of them, x plus 3 and x plus 2. So we're going to divide this. We're going to have to divide it 2 times to get it down to an x squared problem that I can factor with my puzzle and my knowledge to get these two. So it doesn't matter which one you start with. I'll start with this one. So I need 3x to the fourth. So this is 3x to the third, 9x to the third. I need 8 of those, so I'm going to need -1. That's -1x squared, -3x squared. I need my x squareds to add up to -13. So I need -10 more. That's -10x, -30x. I need those to make a -22, so I need 8. That'd be 8. And then remember, you can tell if you did it right, because look, 8 times 3 makes 24. Now, don't go back to the original polynomial. Now you're going to take this one, third degree, see? And we're going to divide it by the other known factor. So now I take x plus 2. And what do we got here? I need 3x to the third. So that's 3x squared. That'd be 6x squared. I need my x squareds to make -1. So this would be -7x squared, -7x, -14x. I need my x's to make -10. So I need +4, 4, and let's see, 4 times 2 makes 8. Okay, so now we come over here and we have to do our timba puzzle. And this one's a little challenging because it's got that 3 in the front. So what two numbers multiply to 12 but add to -7? -3 and -4. And be careful, when this is a 3, you cannot just take these two numbers. Those aren't the factors in there. You're going to have to work backwards with your box. So I know it was a 3x squared and a 4. And these two are what made my 7. So now let's see, what do these have in common? X. What do these have in common? 3x, -4, and -1. So there's your other two factors, x minus 1 and 3x minus 4. All right, last one, number 7. We know these things about a polynomial function. P of x, f of x has degree 3. The leading coefficient is negative. So it's an x to the third. I'll just make up a negative number in front. And it has zeros at -5, -1, and 3. A third degree means the ends are going to be going in opposite directions, but because that's a negative, it's going up to the left, down to the right. And so with this information, all I can really do is go like this, come in. I don't really know what the y-intercept is. I don't have enough information. It's going up to the left, down to the right. All right, guys, I hope that was helpful. I'll see you soon.